Today we are going over note 2.7, solutions of functions. So basically today we're going to analyze a graph or graphs and try to figure out what they're actually telling us. So as we're looking at example 1, we have two graphs. We have f of x, which is a straight line, and we have g of x, which is the curve. And then we're going to answer questions A through E about those two functions. So A asks us to list the labeled points that are solutions to g of x equals 0. So what does g of x equals 0 actually mean? Well, that's the same thing as saying y equals 0. So that's asking you to find the x-intercept. So what's the x-intercept of g of x? Well, there are three. 1, 2, and yes, D was maybe messed up on your notes, but that dot should be on the line. So there are 3 points. Only D is the only labeled one. So that would be my answer. B, g of x equals f of x. So what does that mean? Well, where are they equal means where do they intersect? So where do the two graphs intersect? B and E. B and E. Now they do intersect at a third point, but it's not labeled. Okay, C. List all the labeled points that are solutions to x equals 0 for f of x. So I'm looking at the line. X equals 0 means what is the y-intercept? Right? So they're saying the x-coordinate is 0. So they're asking you what is the y-intercept of f of x? That would be right here at B. Okay, D and E are a little bit more challenging, so we're going to read these a couple times. So all the labeled points on f of x. So looking just at f of x. Okay, so there are possible 3 answers, either A, B, or E. So looking at the labeled points on f of x that are solutions to where g of x is less than f of x. So looking at those 3 points, at any one of those 3 points is the curve below the line. That's what it's asking me. At A, B, or E is the curve below the line. Well, at B and E, it's equal to it. At A, the curve is down here, way down here, right? So A would be my answer. Because at point A, if you're looking at A, the curve is below the line. So that means it's a less than. Now, if you go to E, all the labeled points on g of x. So g of x is the curve. So that would be B, C, D, E, or F. So all the labeled points on g of x where g of x is greater than f of x. So at any of those points is the curve above the line. At B, they're equal. At C, the curve's below the line. At D, it's below the line. At E, they're equal. At F, it's above the line. So this would be F. So again, this is just interpreting what the graphs are telling you. So you really have to understand, well, what is the question actually asking you? Because once you understand that, it's not too bad. Okay, so example 2. Now I have 2 functions. I know that they are continuous. That means there's no breaks. I don't know what happens before the points are given and after, but I know from the points that I'm given that it's going to be nice continuous. I don't know what it's going to look like, what type of curve, but it's going to be continuous. There's no breaks. Okay, so we're going to plot these points. So f of x I'm going to do in green. So we got 0, 0. We have 1, 2. We have 2, 4. And we have 3, 5. So, okay. I'm going to do g of x in red. So 0, negative 1, 1, 3, 2, 2, and 3, negative 2. There we go. Okay, so now we're going to answer the questions. So on the number line below, shade the intervals between integers were the solutions to f of x equals g of x. If there's no solution, explain why. So remember, this means intersect. So on what x values do the graphs intersect? So if you're looking over here, notice it intersects between 0 and 1, and between 1 and 2. So between 0 and 1, and between 1 and 2. Now, I don't know if it's at that 0.5, is at 1.2. I just know between 0 and 1 and between 1 and 2. That's where they intersect. That's when they're equal. I have no clue at what value or what height, but I know it happens between 0 and 1 and 1 and 2. Okay, now, another way you could do this, right, is we're not going to use the graph. We're going to use the table here. So we're going to compare F to G. So in order for them to intersect, they have to change position. So what do I mean by change position? So if one's lower, that means it's got to become higher than the other one. They have to switch which one's higher versus which one's lower. In order for them to switch spots, they have to cross. So at 0, when x is 0, which graph is higher? F. Right? Because it's at 0, G is at -1. At 1, now G is higher. So F went from above G to below it. So if it's continuous, that means it had to cross. So that's why I would shade. Now at 2, F is higher again. So now F was higher, now it's below it, now it's back above, so it had to cross again. So I would shade. Now at 3, F is still higher, so F has not crossed G again. So that's how you'd use the table. Okay, G of x equals 0. Okay, so that's asking you, when does this graph get to a height of 0? Between what x values? Right? What is the x-intercept? Where does that happen for G? So I'm looking just at G. So right now I'm going to ignore F. So I'm going to use the table, then I'm going to use the graph. So when x is 0, it's at -1. That's below 0. When x is 1, it's above 0. So if you're below 0, now you're above it, you had to cross 0. Right? Think about it. You're here, below 0, now you're above 0. What had to happen? You had to cross 0. Okay, now at 2, it's at 2. That's still above. At 3, it's below. So if you're up here, now you're down here. What did you have to do? You had to cross that line. So then you would shade. And let's check. So what are the x-intercepts? Is it between 0 and 1? Yes. And between 2 and 3? Yes, it is. There's my x-intercepts. Okay. So f of x, same idea. I'm going to compare, right, f versus 3. Here I compared G versus 0. Same concept. So now I'm going to ignore G, and I'm going to just look at f. When x is 0, it's 0. That's below 3. When x is 1, it's at 2. That's below 3. When x is 2, it's at 4. That's above 3. So it was below, now it's above. So it had to cross 3. And at 3, it's at 5, which is still above. So between 1 and 2 is my green graph above 3. Yes, it is, right? Here's 3 right here. So as you're doing this, you're welcome to plot the points and use the table. Or I would prefer eventually you get to be able to just use the table and not have to use the graph. But you can use either one right now. Until you get more comfortable, I would encourage you to use both. And go ahead and flip your notes over. So you can plot your points if you want. Right? But I'm going to use the table. So F equals G is where do they intersect? So that means where do they cross? So when you're at 0, right, F is the bigger graph, the higher graph. Okay, when you're at 1, okay, now G is. So that means they had to cross each other. At 2, f is the higher one, right? So they had to cross back. And at 3, f is still higher. So if you were to plot these points on the graph over there, I guarantee they would cross between 0 and 1 and between 1 and 2. That's what would happen. Okay, g of x, so I'm going to ignore f for this, and I'm going to compare g versus 0. So when you're at 0, g is below 0. When you're at 1, you're still below 0. When you're at 2, you're exactly at 0. So that would just be a dot because you're actually at 0. And then at 3, you're above. So this is just a dot because you're actually on 0. When does g of x equal 0? Well, it's not between 1 and 2. It's actually just at 2 because that's the ordered pair. Okay, now I'm going to compare f versus 2. So I'm going to ignore g. And I'm going to look at f. So at 0, it's at 0. That's below 2. At 1, it's at negative 3. That's below 2. At 2, it's at 1. That's below 2. At 3, it's a 7. That's above. So that means you had to cross 2. If you were below it and now you're above it, you had to cross it because it's continuous. So that's analyzing the functions, right? And if you want to, you could go plot these on the graph and you can get your exact answers. You can double check it. I would encourage you to do that. And then the last two are just review from previous lessons in this unit. So it's a quadratic, so I'm going to subtract the 4 over, and I'm going to try to factor this. So then I can set equal to 0. If not, I have to do the quadratic formula. 3 is prime, so this is 3x and x. So multiples of 4, 1 and 4, 2 and 2. So let's try 2 and 2 because that one's easy. It's either going to work this way or it's not. So let's see if it works. 2x, 9x. Can 9 and 2 make 11? Yeah, it can. And it's got to be negative. So then I set each factor. 3x minus 2 equals 0. X minus 2 equal to 0, and I solve. That's the easy one. Add 2. Right here, I'm going to add 2. But then I'm going to have to divide by 3. Oops. And again, you should have hopefully realized it was x squared, so you should get 2 solutions. Okay, now the last example, right? That one's different than 4. Right, it has the grouping symbol, so I'm going to solve it with square roots. I'm going to subtract 9 from both sides. So you get negative 4. Then I'm going to divide by 2. Right, subtract 9, divide by 2. Now I'm going to square root both sides. So coming over here, x plus 3. Plus or minus square root negative 2. So I'm going to get imaginary solutions. So this would be plus or minus I root 2. And then subtract the 3 over. And there you go. Remember, I is equal to the square root of negative 1. Takes care of that negative underneath the radical. And again, it was x squared, so I should get 2 solutions, which is what I got. 2 imaginary solutions. So make sure you answer your essential question.